All right, so physics and chemists, actually a lot of people are just lazy. So if we could find a shortcut to do things, we're going to try to find a shortcut to do things. So the last one we were doing the projectile, and there's one cool thing that we could do. So if we have a projectile and dy is equal to 0, we could do something called a range equation. And this only works if dy equals 0. So I'm going to make a big assumption that that's equal to 0. We do know that this is negative v theta sine theta because, remember, we said before, vf squared equals vi squared plus 2ad. And if this is 0, they're equal but opposite. Okay, so we have 1, 2, 3, 4 variables. Here we have 1. We do know that these two are the same. My goal is to find an equation right there using just variables. So we're going to try to do that. We're going to look for time. And we're going to go, okay, what's the easiest equation that could give us time? And most of the time, it's this one. So we're going to try this one first. It might not work well. It might work. But this is my go-to one. So I'm going to start with it and just, well, I know the answer, but I'm going to pretend I don't. So Vf is negative v theta sine theta, and Vi is v theta sine theta plus negative 9.8. So let's actually keep it as A just to make it cleaner. Actually, let's make it, let's make it A. And then we have, excuse my dog, then we have T. Plug everything in, or move everything. So you have 2 v theta sine theta, and this is a negative, is equal to at. Divide the a on both sides, and you're left with negative 2 v theta sine theta over a is equal to t. I'm going to substitute this over here. Negative 2 v theta sine theta over a is equal to t. And now we have our range equation. Choose a different color so it stands out a little bit better. So d and the x, or our range, is equal to, these two multiply each other. V theta cosine theta times negative 2 v theta sine theta over a. And this is one thing that I hate about trig, is memorizing these things. So let me kind of set it up for us. When in doubt, you could just Google it. So let me pause and get the Google page out for us. All right, so I Googled it. Just trig identities. And then you have the following all over here. And you want to look for one that kind of looks the same. Remember, if we go back to this, we have probably this cosine 2 is important, sine theta. So let's look for something with that. So 2 sine theta cosine theta is equal to sine 2 theta. That's the one we're going to use. Hopefully that's big enough for everybody. Okay, so let me rewrite that. Sine 2 theta is equal to 2 sine theta cosine theta. And let me make sure I did it right. Right here. Let me see if I could, I think it's right here. Oh, I lost it. There it is. Sine 2 theta equals 2 sine theta cosine theta. Perfect. I'm going to rearrange this so that I could have the one I want. So I want to keep my 2. I want to keep cosine, so I'm going to pull out v theta. So dx is equal to negative v theta squared I'm going to pull out the negative, pull out v theta, so I'm just left with, and I'm going to pull out a too. So I'm just left with cosine theta 2 sine theta. And then hopefully that makes sense. If I redistribute this, I should get the same answer, and I do. So then what you do is you exchange that with this. So dx is equal to negative v theta squared times sine of 2 theta divided by a. Now a is technically negative g. So dx is equal to v theta squared sine of 2 theta over g. G is just 9.8. Okay, so here is our range equation. Normally they don't write dx, they just write range. So all you need is your initial velocity at the angle, sine 2 theta divided by 9.8, and that'll give you how far something went. Now, if we look at this, we could figure out a couple things. Sine, remember, if you look at sine, it goes up and down. Hopefully I started off. I think it starts off at 0. I'll be honest. Sine of... Yes, it does. Haha. Starts off at 0, and it goes up and down. And if it doesn't have anything, the biggest number here is +1. The smallest number here is -1. So if I want the furthest range, I want sine to be whatever this entity to be 1, because that's as big as it's going to get. So if I wanted this to be the biggest, it would be 90. So sine of 2 theta equals 90, or 1, is going to give me my biggest answer. So in this case, theta is going to equal to 45 degrees. So at 45 degrees, that's going to give me my biggest number, because sine of 90 is 1. So sine of 90, so 2 theta equals 90, which is 45. Now, the next one was kind of back to the problem that we had. We noticed that 30 and 60 gave us the same range. Plug it in, see what happens, right? 2 times 30 is 60, right? Sine of 2 theta is 60. And then if you do sine of 2 times 160, or sorry, 2 times 60 is 120. So if you look at the, I'm sorry that I'm cramming everything in. If you look at the unit circle, here's 60, and then 120 is right there. And what happens is this angle is 60. This angle is also 60. So they're going to have the same y's component. So they're going to have the same range, right? So sine of complementary angles are going to give you the same answer. So if you shoot something at 10 degrees and then you shoot something at 80 degrees, they're going to hit the same place. 45 gives you the max. The complementary angle 45 is 45. So if you shoot it at 45 again, it's going to hit the same thing. So if you shoot something at 50, and then you shoot something at 40, it's going to hit the same place. So if you don't believe me, try it with a FET. And this is the range equation. But only works if dy equals 0. Cool.